The Indian Army is moving to transform portions of its vast T-72 tank fleet into autonomous armored fighting vehicles, according to the Ministry of Defense's iDEX ADITI 4.0 report released during the 2026 innovation cycle. The initiative signals a major shift in how India plans to preserve combat mass while expanding robotic warfare capabilities, allowing legacy tanks to take on high-risk missions that would otherwise expose crews to enemy fire. The program seeks to convert the T-72 into an optionally manned combat platform equipped with autonomous mobility, remote control functions, and networked battlefield integration. If successful, the converted vehicles could support future manned-unmanned teaming operations for breach missions, reconnaissance, decoy tasks, and contested maneuver warfare, reflecting a broader global trend toward repurposing legacy armor as robotic combat systems. According to the official iDEX ADITI 4.0 report released under India's Ministry of Defense Innovation Framework and confirmed in the 2026 launch cycle, the Indian Army has placed the conversion of the T-72 into an autonomous armored fighting vehicle platform at the top of its new land warfare technology challenges. The move provides one of the clearest official indications to date that India is examining how its large fleet of Soviet-origin T-72 main battle tanks could be transformed into unmanned or optionally manned combat platforms instead of being retired outright. The program suggests that the Indian Army could advance toward trials of its first robotic T-72 battle tank, giving part of the veteran fleet a new operational role inside future manned-unmanned teaming formations designed for minefield penetration, breach operations, decoy missions, reconnaissance, and high-risk armored maneuver. The official ADITI 4.0 challenge frames the T-72 as a legacy platform that has formed the backbone of India's armor profile since 1979 and is due to be replaced by a more modern future platform. However, the same report also shows that the Indian Army is not treating the T-72 only as an aging system to be phased out. Instead, the service is examining how these tanks can be converted into autonomous armored fighting vehicles to augment crewed main battle tanks and support a manned-unmanned teaming operational framework. This is significant because India still operates one of the world's largest T-72 fleets, estimated at around 2,500 tanks, giving the Army a large mechanical base that could be selectively repurposed for high-risk unmanned combat roles rather than retired in a single modernization cycle. The program aims to convert the T-72 into a digitized, remotely operable vehicle while maintaining mechanical reliability and enabling integration with higher-level control systems through an Internet Protocol-based interface. This wording is important because it suggests a conversion architecture built around digital vehicle control, actuator response, remote steering, braking and throttle management, sensor fusion, automation, guidance, navigation, and control. The project outcome requested under ADITI 4.0 is the delivery of 2 fully validated autonomous conversion kits allowing the T-72 to function as an optionally manned autonomous battle tank. The associated testing plan includes laboratory and bench trials, actuator response validation, replacement module testing, sensor fusion accuracy validation, low-speed and high-speed autonomous mobility runs, route repetition accuracy, hardware emergency stop activation, communication loss safety behavior, and mesh mobile ad hoc network resilience. In tactical terms, the converted T-72 would be most relevant in missions where the first armored vehicle entering a danger area faces the highest probability of loss. The official use cases include minefield entry, breaching, decoy action, advanced guard missions, and reconnaissance patrols. In a land warfare scenario, an unmanned T-72 could move ahead of crewed armored columns to test a route, expose anti-tank ambushes, trigger enemy reconnaissance systems, support obstacle reduction, or help engineers identify safe breach lanes through mined terrain. In breach operations, such vehicles could reduce crew exposure during the most dangerous phase of an assault, when armored forces must cross predictable corridors under the threat of artillery, anti-tank guided missiles, loitering munitions, first-person view drones, and direct-fire weapons. The manned-unmanned teaming dimension is the core of the project. Under such a concept, crewed main battle tanks, command vehicles, reconnaissance elements, and unmanned ground vehicles would operate as a connected combat group rather than as separate platforms. A crewed tank or command post could direct unmanned T-72s forward as reconnaissance, decoy, or assault support assets, while unmanned aerial systems provide overwatch, target detection, and battle damage assessment. This would allow the Army to generate armored mass without exposing every vehicle crew to the same level of threat. The concept also fits the official ADITI 4.0 description of a transparent and highly visible digitized battlefield, where survivability depends not only on armor protection but also on distributed sensors, resilient communications, electronic protection, command control integration, and rapid tactical decision-making. The geostrategic logic is also clear. India must plan for land operations across different operational environments, including western desert and semi-desert sectors, plains, riverine zones, and high-altitude northern border areas. These theaters impose different mobility, logistics, and communications requirements, but all are increasingly shaped by drones, artillery observation, electronic warfare, minefields, and long-range precision fires. Converting part of the T-72 fleet into unmanned platforms could provide India with an intermediate capability between existing armor and future combat vehicles. It would preserve useful tracked mobility, low silhouette, armored volume, and 125mm main gun potential while limiting personnel exposure in missions where survivability is difficult to guarantee. From an industrial perspective, the approach also fits India's self-reliance policy by asking startups, MSMEs, and innovators to solve a domestic military requirement through iDEX rather than relying entirely on imported robotic combat vehicles. The wider ADITI 4.0 report shows that the unmanned T-72 challenge is not an isolated experiment. The Indian Army's other listed problem statements include 155mm terminally guided munition, ramjet-powered supersonic loitering munition, 125mm high-explosive anti-tank ammunition for T-72 and T-90 tanks, cognitive electronic warfare systems, smart ammunition and programming systems for 40mm L-70 air defense guns, humanoid autonomous systems for combat, and autonomous load carrier trucks. These challenges point toward a broader Indian Army effort to combine precision fires, robotic systems, electronic warfare, autonomous logistics, and upgraded armored platforms. In this context, the autonomous T-72 is not only a tank conversion project, it is one component of a future land combat architecture in which sensors, shooters, crewed vehicles, and unmanned platforms operate inside the same command network. A similar trend is emerging in Europe. During Eurosatory 2026, Army Recognition reported that Candias France and S2M equipment presented Refurbed, a heavy unmanned ground combat vehicle based on a rebuilt AMX-30 family armored hull and fitted with the Toxo robotization kit and ARX 25mm remote weapon station. That European demonstrator showed how an older main battle tank hull can be repurposed into a combat unmanned ground vehicle with sensors, remote operation, autonomous mobility functions, and controlled firepower. The Indian T-72 concept follows the same broad logic of extracting new tactical value from legacy armor, but with a larger potential fleet base and a direct connection to main battle tank formations. If India retains the T-72's heavier battlefield role while adding remote or autonomous operation, the result could be closer to an unmanned battle tank than a light robotic fire support vehicle. The main challenge will be operational reliability under combat conditions. An unmanned T-72 would need resilient communications, cyber protection, electromagnetic hardening, navigation in degraded or GNSS-denied environments, obstacle detection, sensor protection against dust and mud, safe stop procedures, and clear human control over weapon employment. If the first prototypes validate these requirements, India could open the way to a phased conversion of selected T-72s for trials before broader operational deployment. The program would not eliminate the need for new main battle tanks or the future replacement of older platforms, but it could give the Indian Army a practical bridge between its large legacy armored fleet and future manned-unmanned teaming formations.